So I'm going to jump back into now as my controller, my account controller, to create my account. So on postback, my create VM parameter is going to have all of those field values in there. So the first thing that I want to do is I want to validate my model. And you can do that by simply saying if model state.isValid, or actually we're going to say if it's not valid, return the view with the create VM. And all that does is says if the model state isn't valid, go back to the view, and when you go back, pass the data that was just entered into the view back. And that will cause it to repopulate the field and actually generate an error message on the screen. So we'll just say validate model. Now we'll validate password versus password confirm. And that's simply if create VM.password does not equal password, create VM password confirm. Actually, let's do 2 checks. If not, let's see, string.is null or white space, create VM.password. Then error on password required. And then we'll say if these don't match, error on passwords don't match.
Shouldn't that already be taken care of, though?
That it's required?
Yeah.
It would be unless the person that was submitting the form had JavaScript turned off in their browser. Or they generated a curl call that actually just did a straight form submission instead of using a web browser. So there are cases where your JavaScript event or error handling is a good first line of defense and it saves you trips back to the server, but it's not always best to assume that that's the case. Now, that being said, I often forget to do all of my validation on the server, as well as you probably will too. It's not a best practice, but sometimes you get the cart before the horse and you forget to check everything again. So it's life. That's where errors come in, that's where bugs come in, and that's why you have to fix your code. All right, so we've got these 2 errors. So how do we push error details back to the user? We do that using model state.add model error. So the model error is associated or is sent up in a pipeline. So basically you add errors to the pipeline. So here we're going to say the key. The easiest way to just do a generic error is to do double quotes. And then you can pass either up an exception or an error message. In this case, we'll say password is required. And then we'll return the view just like we did above. Model state.add model error. We'll say password and confirm password do not match. Return view, create VM. Now technically, what can happen here is that we could actually call these 2 functions prior to doing the model state validation. And we would only have to return the view once, because by adding these errors to the model, we would force the model state to be invalid. So these lines of model state that add model error will trigger model state that is valid to be false. We could move both of these if statements above and then use that as the last check. They're already there, so I'm not going to worry about it. But if you want to consolidate the amount of code you're writing, moving that around would be ideal. These are explicit so you can see them. All right, so at this point we're going to assume everything is good. We have the data we need. So next thing we're going to do is we're going to create our DB context. Whenever you're using an unmanaged resource, and unmanaged resources fall into 2 or 3 basic categories. You're connecting over the network, you're opening a file, or you're using some sort of unmanaged access to some resource. So basically something like a peripheral or network or, again, file storage. Those are considered unmanaged resources. Prior to the .NET Framework, you would actually have to do a lot of work in order to establish network connections, to open up file access, and to access peripherals. Because of that, the under system that .NET sits on top of, that runtime, still has to utilize those unmanaged resources. Therefore, when you're done using them, it's very important that you close off connectivity to those resources so that you release the network adapter from being hung up by utilizing that resource. You release the SQL server on the other end of that network connection and tell it, I'm done, thank you. Otherwise, it keeps a serial connection to your device. And it assumes that it's going to be having communication with it over a long-standing period of time. That then takes up threads and sockets on the other end, and it's just sitting there waiting. It's like sitting in a room trying to have a conversation with someone that doesn't have good social skills. You just stare at each other, and then it gets awkward, and then you don't know what to do with yourself, and then that's kind of what the server feels like. So, you clean up and you dispose of your resources. And the other analogy was the file, where the file's open but nobody's writing to it, and then everybody's like, hey, can I read from that file? And they're like, no. And they're like, you using it? And you're like, no. But it's mine. So within the .NET Framework, you have a iDispose interface that can be implemented, and that interface brings along with it a dispose method. Now, you can call it dispose explicitly, or within the C# language, there's actually conventions that allow you to do it implicitly, using enclosures. So you use using statements. So here we'll say using, and then we basically do a declaration. We declare the object that is disposable that we're going to use. Project DB context, my B is capital, and I'm just going to call it context equals new project DB context. Curly brackets. Now, the purpose of the enclosure is that anything that's inside of the curly brackets has access to that resource. Any code that falls outside of the curly brackets no longer has access to that resource and assumes that it's dead. When you hit the bottom of the curly brackets, dispose gets called, and in a file system scenario, the file stream is closed, you can no longer read or write from it, and it's released back to the operating system. The network scenario is similar, database connections are closed, resources are released, and you can no longer connect to the database. So any work you want to do in the database has to be done within the context of that using statement. So in our case, what we want to do, actually before we do the connection part, and this is the other side of this, is that you want to minimize the amount of time this connection is active. So you want to do as much work as you can do before you open the connection. And then once you've opened the connection, you want to do the work quickly and get the connection closed as fast as possible, and then continue doing work. You don't want to open the connection, add a user to the database table, and then go on and do 15 other things, still leaving the database connection open. So once you're done with it, you close it and then go on to the next task. Again, it's that whole awkward situation. So what I'm actually going to do prior to adding the user is I'm going to create the user. So to create the user, we're going to create a new object that is a user DTO. Now, you've probably seen it done this way. And that's just fun, to type all of that over and over and over again. There's actually a shorthand notation that you can use within C# 3, maybe 4, I don't remember. And it looks like this. It assumes that whatever's on the left side of the equal sign is a property or member of the object that you're instantiating above. And it looks like this. And then you use commas instead of semicolons. And if you really have fun with it, I like to do this. Copy, paste, email, paste, what else? Password. That's it. So we're creating that user object prior to opening the database connection. So then we open our connection. We go into our context. And we say context dot, and we have our users property in here, users dot add. And you may be wondering, well, where did add come from? Does anybody know where add came from? What was that?
Object.
Object.
Everything inherits from object.
Everything does inherit from object. Add is not one of the methods that comes off of object.
Or DB entity?
DB set. Yes. So that DB set generic, that enclosure essentially, gives us all of these methods. So we say add, and then we pass in our new user object. And then once we've done that, we tell the context to save changes, and I'm going to choose save changes async. There's actually two methods here. There's save changes, and there's save changes async. And that requires the await keyword in front of it. I won't go into all of the detail around async and await. There's plenty of videos up. I will go ahead and post a couple up for those of you who may be interested to watch them. I'll include it with the homework part. If you don't care, that's fine by me. Basically what async does for you is it says that this is an asynchronous process which is not bound to the CPU. It's I/O bound, which means that your computer is attempting to make a connection out somewhere, or it's attempting to utilize one of those unmanaged resources, and instead of the computer sitting around idly and waiting for the SQL server to respond back, it says, I'm going to go ahead and make that call, and I'm going to add like an event listener for it. And while I'm waiting for the event to come back, I'm just going to sleep. I'm not going to tie up the CPU. I'm actually going to pause the thread that's currently executing in the case of our web server, and I'm going to go take some new requests. And when the SQL server comes back, I'll spin up a new thread, capture that response, and then continue executing your code. So you actually get up with a form of asynchronous programming or multi-threaded programming by utilizing this approach. So you utilize the await word, and then if you remember at the top there, I had an async keyword at the top, and you're utilizing these tasks in order to make all of that work. So basically the caller of this will call, it will get back a task object. That task object is the listener, and then ASP.NET says, go ahead and do your stuff. Let me know when I need to pause. I'll put you on the sideline. When you are ready to come back and respond, I'll pick you back up, and then we'll keep on running. So it's more efficient coding. Typically, asynchronous processes, or asynchronous programming as this is called, is done from the top to the bottom. So that means that everything that you do, how should I say this? if you're calling something that's asynchronous, it's calling something that's asynchronous, or it's performing an asynchronous task itself. Vice versa, if you're calling something, if you're building an async method, then the thing that's calling your method should also be async all the way through the chain to get true asynchronous execution. MVC handles async methods. It's actually one of the things they introduced in ASP.NET 5. So it's the best approach to use to get the most efficiency out of your applications. All right. So await, and then we call that save changes. So that's actually performing that insert statement into the database. And then from here, I'm going to do some sort of return, redirect to action, and we'll redirect to login, I guess. That'll be the easiest. All right, so we'll save that build, and we'll see if it works.